Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, I think we're going to start now. So get comfortable. So hopefully we'll have an interesting panel session now, hopefully some very lively debate. We had a great session last year on software for science and kind of what was wrong with scientific software development, and we could have gone on all day. So I'm hoping that this session will be as vibrant and lively. And so it's pretty general. So the title, Cloud Computing, What Do Researchers Want? Okay, so the structure of the session is like this. So we're talking about cloud computing for research. First thing I want to think about, so these are questions that you have to answer, okay? These are questions for the audience, okay? Why are you using cloud? So if you are using cloud computing, why are you using it and what is it good for? Second question, why are you not using the cloud and what is it not good for? Okay, these are questions again for you, so you can think about this whilst the speakers are giving their talks. And at the end, the most important point is, what's missing? What could be done to make the cloud better for your research? Okay, so think of this as a gap analysis of cloud computing for research. Okay, so these are the three questions that we will pose after our four speakers, okay, who have very short talks, I hope. So we have four great speakers here. So we have Dennis Gannon, hot off a delayed aircraft from Seattle, who got here in the nick of time. So I'm very pleased to see Dennis here in the flesh, who is in Microsoft Research and recently joined the Microsoft Connections team, who's heading up our cloud computing activity in Microsoft Research Connections. So he'll be followed by Marty Humphrey, who has been doing eScience and more recently cloud computing at University of Virginia, and he's going to be talking about what researchers are using the cloud for today. Yep, exactly, by a bright light, exactly, the spotlight from your Chicago Marathon. So, and then Fabrizio Gagliardi, who's in Research Connections team in Europe, will talk about some of the experiences through one of our large projects where we actually have looked and spoken to researchers about what they're using for cloud for. And then Paul Watson from the University of Newcastle will be talking about some of the issues around cloud computing, and then we will get into an open discussion. So that's the structure of the session. So I'd like to hand over to Dennis.
All right. I believe you can hear me. So I was given this assignment, what does cloud for research mean? And so this is just very general, you know, so what do we mean by the cloud? And first of all, the cloud is a host for computational services and data in its most general form. Big companies like Microsoft, Amazon, Google, these clouds that they've built are based on massive data centers. In the scientific community, there are other things called clouds. Just about everything now is called a cloud, as you know. But this is what we mean. We have a number of really big centers scattered around the world for our cloud that we use for Windows Azure. There's two of those, two sites, big sites in the US, two big sites in Europe, and two big sites in Asia. And these are really big facilities, and they span a range of generations from the early machines, which were built by putting big racks of equipment in place and wiring it all together the way things used to be done, to the point now that we started working with containerized servers, and we pull things together in big, really self-sealed unit containers, and now to our next generation, the fourth generation data centers, where there's a blow up of an artist diagram of one of the next generation centers. We don't even bother with a building anymore. Everything is in a container. It's spread out over a massive chunk of real estate, and everything is air cooled. You just have each one of those containers contains about, I guess, about 1,500 servers. All you have in each container is 3 connections. You have the network connection, you have a small cooling connection, and you have power. And that's all it takes to build a data center. You just assemble it that way. Now, on to what are the attributes of clouds that make them interesting for science? Well, first of all, the cloud is designed, and this is a distinction from what I think of as a supercomputer. It's designed for 24/7 on-demand access to services by thousands of concurrent users. Okay, that's fundamentally different than what we see as a supercomputer. There are, however, some things that are making these converge. Okay, services run in one or more virtual machines. There's on-demand scaling and descaling. So if you create a service that talks to, and what do I mean by a service? If you've got a cell phone these days, and I think you all know this, the general audience, I have to explain this, but if you've got a cell phone, you're probably using a lot of cloud services already. Anything that's interesting almost always runs on the cloud. And your devices talk to a service. The service exploits all the data. It can be scaled out, up, or scaled down as demand is needed. You can geo-replicate your services, compute and data resources. You have online access to parallel and distributed data collections. It's not a supercomputer, as I said before, but what we're starting to see, both with Amazon and Microsoft, is embedded HPC clusters for the applications that really do need the HPC, MPI, fast network connections. And all of these things are designed to support massive scale data analysis computations. So what do I mean by research, or cloud for research, is supporting communities. That almost fits on the slide. And building research marketplaces. So where I think the cloud will have its biggest impact in science is when we have large-scale data collections and lots of users that exploiting services and capabilities of that a community needs. A cloud would be outfitted with advanced data analytics and machine learning libraries, curated data collections, data upload, curation and visualization tools, and strong support for building science gateways. If those are familiar with that term, that's another name for a science service sitting in the cloud, as well as tutorials. Now, for example, I think some of the work being done with IPython, it's a picture of the IPython notebook now running on our cloud, Java, C#, F#, C++. These are all of the tools that you need to build cloud services. So that's my context for what I see as the cloud, and my 3 slides are done. So next.
Great job, Dennis. I don't know if anyone has a burning question for Dennis while we switch over
Any burning questions?
to Marty. Plenty of time for discussion afterwards.
All right, Marty.
So not too controversial then, Den.
One of the things that's not on the slide is strong tool support for proprietary languages.
Proprietary, like, for example,
MATLAB.
MATLAB in particular. That's right.
Yeah.
Yes, and I agree with that. Just like everywhere else, clouds and supercomputers, somebody's got to buy a license. And I know you've personally had to deal with this challenge quite a bit, as well as some of the other proprietary statistical packages. If anybody from MathWorks here want to help us out on this? I think that's right. The comment was they haven't figured out the business model. I think they might be close to it. I don't know. I hope so. But I agree. That would, we now have R. For example, Jack Dongera and his colleagues now have a little really nice company which has R in the cloud. That's really exciting. I saw a demo of that recently. It was very good, and we've got everything except for MATLAB.
Well, what about Esri? Same.
And MATLAB and all the other commercial.
Yeah.
There's another question back.
Just wondering when you're going to move some of the cloud down into the southern hemisphere.
Ah, good.
I mean, Singapore's pretty close, but
Not that close. I know I've flown between them. I know the data moves a little faster than the airplane, but that's a very good question. I would love to see that. Actually, now, well, there's some some things coming out of, at least for Microsoft, coming out of the Windows Server group that enable us to actually build out something on a scale around the latest edition of Windows Server, which has support for all of the Azure capabilities. But building a big data center is what I'd love to see in Australia. I'll talk to the CEO about that, see if we can get that fixed, because I would love to see it.
Okay, great. I think we'll move on to
All right, we'll come back to that.
Yeah. We want lots of questions for afterwards, so save them up. Okay, over to Marty.
So I'm Marty Humphrey. I'm a last-minute replacement for Jeffrey Fox. If you like what I say, I'm Marty Humphrey. If you don't, I'm Jeffrey Fox. So, I'm supposed to talk about why is the cloud a good fit for research. My goal is to paint an overly rosy picture of the cloud, enough to make you object and throw stuff and get into a nice discussion at the end. I apologize for that last line. I don't know how it got up there. So why is the cloud a good fit for research? I'll state the obvious, which is arguably theoretical. Sometimes in reality it's not quite this, but just remind everyone of the obvious. We have seemingly infinite data storage. Researchers like that. Seemingly infinite data processing. Everything's fairly cheap and only getting cheaper. Let's see, no late night calls to sysadmins. Doing it within the enterprise, you have those, and so we'll eliminate them completely. A lot of this is driven by commercial entities, and so you have the best aspects of competition amongst companies, meaning they're going to do everything to get your business and to drive costs down and to innovate. So you're going to get more features. It's going to cost less. It'll be more reliable, and you won't have to do a thing. Hadoop is a wonderful data processing engine. There's a large community continuing to build around Hadoop. And so all this sort of paints a picture of we don't have to build the infrastructure anymore. I mean, that's been our goal, frankly, for a long time. Researchers would like to use the cloud because they don't have to build their own infrastructure. They don't have to go on that tangent, right? Now, so if we take a step back, however, and ask how are researchers using the cloud, there's actually kind of two branches. One is this branch of it's fine, and we're just going to use it. The other branch you go into sometimes is it's broken and we're going to fix it. And so let's just look at each of those just for a couple moments. Examples of how it's fine, how people are using the cloud for research right now. A very concrete example is the NSF call that went out a couple of years ago and was awarded last year. And so this is kind of fascinating to look at just for what National Science Foundation picked as projects to use the cloud. And you sort of look at each of them, and it gives a nice broad picture of the way the cloud is being used for research right now. And there's, again, I emphasize the broadness of it. There's a lot of different dimensions of the different projects. There's security, there's data processing. This is a really good, fairly comprehensive list, small scale, and it is subject to an NSF panel, but there's a lot of different ways that people are using the cloud right now. There's a lot of infrastructure that can be used for a lot of different projects, and that's how people are using it right now. Now, if you go down the branch of it's broken, if you attempt to assess how the community thinks it's broken, one way in which to do that, the way I did that was I looked at two of my more favorite conferences and workshops, the Hot Cloud and the ACM Symposium on Cloud Computing, which I guess takes place next week. These are the ways in which people think that it's broken. A lot of those topics tend to be what you've seen for a long time. We have a decent emphasis and decent experience looking at some of these. Data centers arguably provided a different context, but a lot of these problems, we have some idea of what they are and how to tackle them. So, if you put them both together, why is the cloud a good fit for research? If you look at both branches, no matter what camp you fall into, there's arguably a compelling plan going forward. The it's fine path, if you choose to believe that the cloud is fine, then there's good reasons for you to go down that path. Similarly, if it's broken, if you believe that it's broken right now, there's a lot of people working on it. It's only going to get better. And so no matter what side you're looking at, arguably the cloud is a good fit for what you're trying to do. Now, hopefully I said something objectionable, but we can discuss that afterwards, I guess.
Thank you, Marty. Has anyone got any questions for Marty just while he's up here on his own? Otherwise, we'll hand over to Fabrizio. Okay, great.
Okay, very good. By the way, I didn't run the marathon, but I was stuck 5 hours on the airport coming here, so I think it's longer than 3 hours and 40. So again, I don't think that previous speaker has been as controversial as Kenji was hoping. And again, my short communication will not be that controversial either. I just pinched from Dennis Gannon standard cloud deck for science, the long tail, but that was covered by the keynote speakers this morning, by Drew Purves. So definitely what I think I found interesting is the confirmation that more and more you can do science, a small group of people in a remote location, and those people traditionally didn't have access to big computer resources. And probably the best they had was their laptop or maybe some departmental cluster. So I think that is what people now understand more and more. You have the top of the scale, the people like my former colleagues at CERN in energy physics that know how to design and build a complicated computer system. The grid was a very popular model there and still is. And they demonstrated they could discover the Higgs with a very large worldwide, more than, I lost the count, more than 200,000 processors scattered around the entire globe. So that is going to stay there, I think, for certain communities. And we have, the closely embedded computational scientists working in a computer center. Good example I was very familiar with is Barcelona Supercomputer Center, where you have earth scientists, chemistry, many other really work in the same building, because those people they do need high response time. They do run programs that need MPI libraries. They do need fine-grained parallelism. But everybody else, as we said, can really do with commodity computing that is now delivered over the network. And that's basically what the previous speaker were speaking. So I want just to give another, let's say, more funding agency angle. And that is, again, is nothing controversial. I'm stating the obvious because I heard that discussed in many, many meetings. Public funding agency, or National Science Foundation, Department of Energy in the United States, the European Union, with which I'm more familiar in Europe, they found at the level of billions research, and all research project they found, there is more or less a good fraction of the grant that goes to provide computational resources for the project. So in certain cases, they can use a computer center or other, already established computer infrastructure, but often they go out, and the easiest solution is to buy a cluster, run in Linux, Windows, whatever, and that is normally managed by a bunch of PhD students, and 2, 3, 4 years later, the project is over, the PhD student, hopefully go and do something more useful, more interesting, And well, the hardware basically get decommissioned, and that's not too bad. I mean, after all, you know, old people like me that get their salary paid from IT industry, well, it's good that people buy hardware and they throw it away. It's good for the business. But what I'm worried is what happened about the data. Now, not all the data produced by NSF and European Union supported projects are useful, but a large fraction of those are. And we know that more and more the funding agency require the data to be widely available. If the data are produced with public funded money, then they should be made available to the entire scientific community. And that's not easy if at the end of the project everybody goes. So at the best, what people do is just to archive the data somewhere on some removable media, and that's probably the end of the story, because 2-3 years later, if you want access to the data, no way. So the only way to preserve the data is to make them available over the internet, and that basically means that with an entire virtualized data storage that you can do more easily. So it's nothing that you could not do before without a conventional approaches, but I think really the virtualization that we reach today allow with cloud-based computing solution for funding agency basically to virtualize one step more. So really virtualize the grant that goes to support computer resources. And if you make a simple calculation out of the European Union spent basically 1 billion euros around per year to support research. So even if only 10% goes to invest in a cluster, let's say volatile hardware, is 100 million. So with 100 million, you can provide and procure a lot of data storage on the cloud and a lot of computer service. So I think my assumption for discussion here today is by using cloud computing the way the previous speaker presented, we are leading to more science per taxpayer, euro or dollar or whatever. But is cloud good for any kind of science? Well, I don't believe so. I mean, as we said, there are, the top of the pyramids or the curve still require other solution. And in Europe, to try to assess what the cloud is good for, and not only that, but our cloud-based solution could integrate with supercomputers, with cluster, etc. We started 2 years ago with a strong support and investment also by Microsoft Research and Microsoft Corporation that provided basically a considerable amount, through Dennis and his group, a considerable amount of Asia resources. We started and we ran this Venus C project, and you can get more information on the web. We completed a couple of months ago with a pretty good performance. And there we built about 27 different user community. And at the end, we basically asked each of the user community to assess their experience, moving application to the cloud or developing from scratch. And we use those parameters: performance, error management, scalability. Scalability is what Dennis was explaining before, completeness, interpretability, the learning curve of working in this kind of new computer infrastructure, convenience and robustness. And the results, in a nutshell, I don't want to take too much time, the results are basically this one. So you see that the scale is 1 to 5. So 5 means it's very good and 1 means it's very bad. So you see that out of this 27 user community, we got a pretty good score. So more than 80%, they score between 4 and 5. Now, it is a little bit, of course, biased, because the people that have been filling the questionnaire, people that they really wanted hard to experience the cloud. So I think the mood in which they entered the project was a very positive one. But even taking that into account, I think that is a pretty good result that really would like to share with you and discuss. And that's basically it.
Okay, thank you, Fabrizio. So we'll just switch over to Paul. Any questions for Fabrizio just while we're switching over? Oh. Okay.
Since Fabrizio used one of my slides, it contained an error that I want to correct in case anybody from the NSF is here. The NSF does not require all data to be made public. NSF requires that everybody have a plan. And they don't. Right. So those of you that were panicking because you have NSF funds, and you weren't, and your plan did not say make it public, you're not in trouble.
Yeah. On the other hand, it is fully true for the European Union. So if you get European Union money, be prepared to make your data available.
So yeah, in the UK, that was mandated last year, I think, that all publicly funded research, you had to make your data publicly available. And that's a requirement. And the penalty for that is you won't be eligible for funding. So it's a big stick. So in the UK, the requirement was, because I was one of the people on the working group, was within a year of a piece of data being produced, it must be catalogued on a web-accessible site so that anybody can find out about the data. Okay, so within a year of the data being produced, it has to be in a publicly accessible catalogue. At the bottom of it, it could say, email the university so they can recover the USB hard drive that it's on, which is fine. But, so it has to be available. So,
You have an embargo period of 1 year where you can...
And there was a big discussion about privileged use of data for publication because they were trying to protect, obviously, the researchers' first use privilege of their data, whilst also complying with a sort of nationwide open access type policy. So it's worth having a look at the UK RCUK data policy because it's pretty interesting. So, and Paul is in fact from the UK, so from Newcastle, so we can discuss that in a bit more. So over to Paul Watson. Yeah.
Okay, thanks, Kenji. So we've heard a number of examples of why clouds are a good thing, and personally I think that clouds have the potential to really revolutionize science, this fantastic ability to give people the resources that they need as and when they need them, has the potential, I think, to really democratize science and shorten timescales and cause a step change in many different areas. But what I want to talk about is why then, if this is the case, why aren't clouds used more often? Why is it only a small proportion of research that can actually exploit cloud computing? So over the last 5 years, I've been working in a group that's collaborated with scientists across a whole range of areas, from X-ray spectroscopy through biology, through chemistry to archaeology. And so we've got experience of trying to work with a wide variety of different sorts of researchers, both in academia and industry. And based on that, I want to talk about what I see as being the 3 barriers which are currently preventing cloud computing from being more widely used. And I want to talk about these, not because I want to be the doom and gloom merchant in this group of speakers, but because I think that a community like this could actually address these issues over time, and so open up the benefits of clouds to a much wider audience. So I'll go through the 3 barriers now. So the first one is building cloud applications. So one of the great things about clouds is that you can get resources that you need when you need them. Unfortunately, there's 2 things that you need to do if you're to exploit cloud. So one is to get the resources you need, but the other one is to write the software which exploits those resources. And at the moment, in the main, it's something like this. A few heroic individuals or groups are working with very low-level cloud infrastructure and building these siloed applications from the ground up. And I think one of the sad things, almost a catch-22 for cloud, is that if you look at those researchers who could benefit from cloud computing, the majority of them can't benefit because, although they can get access to the IT resources, they can't actually write the sorts of applications that they need. And an analogy I'd make, it's a bit like taking a researcher into your machine room in your university, researcher who knows they could cause a step change in their particular area of research if they could get access to IT resources, if they could build new sorts of applications to analyze their data, generate new results. And it's a bit like taking those researchers into your machine room and pointing them at all the servers and saying, there you go, all your problems are solved. We'll give you access to this, and you can do whatever you want on them. And I think things are made worse in science because I think in general, if you distill what scientists want to do, then they don't just want to really knock up some simple application. In the main, they're looking for applications that are scalable. They need to deal with huge amounts of data, large numbers of processes if they need to parallelize what they are doing, potentially large numbers of users if they're really to have an impact. And then it needs to be reliable. It's no good if they build systems which keep falling over if the users become dissatisfied. They'll move away from these cloud services. And finally, security in many areas is really important, be it medical research or perhaps even in companies where they've got business critical data. And as we all know, finding people who can build scalable, reliable, secure services, well, it's a very hard challenge to find those people. So this is my barrier number one, that building cloud applications is actually hard at the moment because we're building from a low base. So the challenge I would make to the community would be, how do we actually raise the bar? How do we produce cloud middleware which makes it easier for researchers to exploit the potential of clouds? And this brings us neatly to barrier number two, which is security. So if you talk to somebody in an IT department, a typical person in an IT department, and say you're thinking about using cloud computing, then they might well say, oh, I wouldn't do that, not secure, you should use our own internal resources. And I've heard it said by a salesman who was trying to sell cloud into organizations that you never go to the IT department. He said, selling it to the IT department's like getting turkeys to vote for Christmas. He said, they'll just never agree to it. You should go to the finance director and sell it to the finance director. But there are real challenges. It's not just a story put about by IT departments that there aren't issues. So this is a typical workflow that we have been involved with in one of our projects, and it's with some medics. And you've got some data which is a mixture of patient data and some accelerometry about their activity, and then the pipeline effectively strips out the patient data, just leaving you with the accelerometry data, and then you do the core analysis, and that's the thing which takes all of the effort. That's where you'd really like a cloud, so you could scale out that sort of analysis, and it produces the results at the end. And so how do you decide where you can run that? Can we run this on a cloud or not? There's patient data for some of it. And this is exactly the sort of issue that people trying to build cloud applications come across when you talk to, say, medics with medical data. What we try to do is we have this system which we created to address the first problem, which was to produce some middleware for science that runs on clouds. And we can run this internally on a private cloud, as you call it, so you give us some servers and we put this up, or you can run it on a public cloud like Azure. Now, that means that when we have these discussions, we can say, depending on what the medics think and what ethics forms are filled in, okay, we might go down the left-hand branch because we don't take any of this data out to a public cloud. But then, of course, you lose all the benefits of scalability and so on that you get from cloud. So then the issue is, well, could we split this pipeline up, for example, and run some of it internally and some of it externally? And that's a possibility. But even then, what you find is that sometimes you're not making these decisions based on technical values, but you make them on socio-technical issues. People just feel that their own servers inside their organizations are much more secure than those external servers that are out there in the public cloud. And so this isn't a problem that we can solve with technology solely, although I'm sure there are technological solutions, tools, and techniques that we can use to try and increase the range of applications that people are comfortable with moving out onto a cloud. We also need to deal with that trust issue as well. So I think the question here is, how can we build up trust in clouds, partly through technology, but partly through arguments about the relative benefits of private service within organizations and public service in the cloud. The final barrier, which is one that we've seen more in the last year or so, but we didn't really hear much about 2 or 3 years ago, this is to do with governance. So the issue here is that this is a traditional organization that we might have seen about 5 years ago, where if you wanted to do anything with a computer, then you went and talked to your internal IT department. And there are these stories, I'm not sure whether they're apocryphal, but now about people who go to their IT department and say, I need to create a new service. I've been given some data to analyze. My boss says it needs to be done very quickly. And the IT department says, okay, well, we can meet you and discuss it 2 weeks on Tuesday. And so what happens is that the hero of this story then just goes out and grabs cloud resources, analyzes the data, gets the results back, and his boss is delighted. The hero gets promoted. The boss is able to release a new product out into the market more quickly, and the company makes money from it. Now, the part of the story that nobody ever tells, which is because I just invented it yesterday, but this is something which suggests that this is something which we're hearing more and more about, is what happens next is that the company a year later has an FDA audit, and the auditors come in and ask to see the data that's been used in producing this pharmaceutical product. And so the boss goes to the hero and says, where is it? And the hero says, well, I put it on my credit card. I'm obviously, once we got the results, I've stopped paying for it now. There's no way we can get it. And so the end of the story is that the company gets fined a large amount of money, and our hero gets sacked in the end because he hasn't managed to retain the data according to the rules that the company is supposed to obey. And this is a problem that didn't used to happen because the boring, slow internal IT department, when you went to them, they used to negotiate the SLA with you. They'd ask sensible questions about, well, how long does this data need to survive? How much does it need to be? How available does it need to be? Who's going to pay to keep it up there for the length of time that we need to keep it? And this is going because of people going directly out to clouds. And this is an interesting barrier, I think, because the barrier is not one that's caused by the cloud. It's not a barrier that's caused by the researcher. This is a barrier that's being now put in place by people high up in organizations who are starting to worry. For example, we just heard about data retention, research councils. It's those sorts of issues which are causing heads of universities and heads of labs to worry about these sorts of issues. So unless we address these sorts of issues, then the problem will be that more and more there'll be restrictions on the use of cloud. So the question is, I think, how do we get the benefits of cloud while still keeping the right sort of governance that organizations need? So those are the three barriers that I wanted to raise. I think that you can see two futures. So one future would be that we keep going as we are at the moment, and so clouds are only exploited by a small proportion of researchers. Or the other future is one where we try to address barriers such as these, and then we dramatically increase the proportion of researchers who can benefit from the cloud. Okay, thank you.
Has anyone got any questions for Paul? Just while he's up here. One over there. Let me just double up the microphones.
Thank you for your very clear presentation. If I understood correctly, then two of the barriers are caused by internal IT departments.
I think it goes deeper than that, actually. So I think that it's easy to say these are caused by just the fact that IT departments are just fuddy-duddy, stuck in the mud, don't want to move forward into the brave new world of clouds. But actually, that's a real issue. How do you retain governance? And in the case of security, it is a real issue about medical data or business confidential data going out into the cloud. So I think, although I presented it initially through the eyes of the IT department, I think these are real issues that we do need to address.
No, I can imagine, and I heard the stories from researchers myself. So, but I would like to know, how do you see the role of the IT department in the cloud?
Well, I think that if you look at all of these issues, so the issues about governance, if you look at the issues about security, if you look at how to build these systems, these are roles that the IT department could take on. So if they could move up the stack from managing hardware and start to support users to get the most out of clouds and deal with these issues, then there's a future for IT departments. Whether they'll do that or not, I don't know.
I actually think that this is starting to happen. You see this within the universities. In the private sector, it's going on all the time now. The IT department is negotiating with the cloud vendors. The number of companies that are operating in the cloud, I mean, seriously operating on a very large scale, do it through the negotiation of the SLA with the cloud vendor. The IT department is deeply involved. In the case of the universities, we've had discussions with many university CIOs about how to integrate the commercial cloud into their organization as largely for the data scalability and analytics capabilities to complement their supercomputing capabilities. So I think it's starting to happen, and I think that's where it has to happen, is through the IT department.
Yes, thanks for this. I'm wondering about data portability from the cloud. I think that's a big issue, that if you're stuck with one cloud provider, whether it's Microsoft, Google, or any other, that you're stuck with them for the rest of your life, because there is no data portability standard or whatsoever currently being conceived. So I'm thinking, how could we as a community say somehow force them or work together with the cloud providers to get something on this data portability going on? And any opinion on that, maybe?
I always have opinions. Actually, there's a number of things that are happening on this regard. There's a Research Data Alliance, which is a new group, European, U.S. managed group of researchers that are taking a look at a lot of issues. Not directly the portability issue, but in terms of the common standards about data models. They just had their first meeting a week ago, and that will be a large effort. You also have, this is the lock-in argument I've heard many times. I've got my data here, and I'm trapped there for life. Oh my God, I'm stuck. Well, that happens wherever your data is, whether it's in a commercial cloud or in, I used to have big stacks of tapes. And I don't have them anymore, but yeah, that's really locked in, that data. Anybody else want to talk about lock-in?
Yeah, we have been struggling and discussing with that also in the context of the funding agency in Europe with the European Union. In fact, as part of the Venusi project mentioned before, we did try to offer our end user an extra layer where they could be somehow isolated from the infrastructure. But it also depends very much how the volume of the data, because so clearly energy physics that produce 15 petabytes of data per year, there is very serious, because whenever and whatever you do, it's very difficult to retrieve those data. That's why I think we should always go back to the idea of the long tail, so for a relatively small group of scientists who cannot really use high-performance computer resources, who don't handle gigantic amount of data, but the data are much more modest. And there, the data lock-in is much less of an issue. But for big producer of data like energy physics, that is a big issue. Yeah. Each one, yeah.
So just so the question was about the long tail and the fact that many scientists with less data is still a huge problem. So Dennis.
Right. Oh, I agree. One advantage of the fact you've got many scientists with smaller amounts of data is you could actually move data much better that way. You have more concurrency in the data streams, and so you get higher bandwidth. But I also wanted to mention, I forgot to mention this before, there's organizations like the Dataverse organization out of from Harvard, who have been building out infrastructure for collecting and cataloging data across multiple repositories. You also have DuraCloud from MIT, which is another very interesting one. And so these are infrastructures for data and data cataloging and curation that span multiple institutions. You can do automatic replication between things, and this helps. I mean, I'm interested in all these. This is a really important question for scientists.
Yeah, I have two questions. One is for Dennis specifically. Could you brief us a little bit on the HPC and the auto scaling of Azure? And another question I have is for everyone is about cloud computing and big data. We know that we have data ranges from megabytes or gigabytes, petabytes to terabytes. What's the pros and cons of migrating those big data to the cloud platform, either commercial or your own private or community?
Okay, so the first question was about auto scaling and
HPC support of Azure.
Okay, so HPC support on Azure. I invite you to come to it is coming, and the details will be available at the Supercomputing Conference in Salt Lake City. And I don't know how much has been made. It's been made public that it's coming. So you should talk to the Amazon people who actually have this all now commercially available. In terms of auto scaling, that happens. There's a standard API for doing that, and you can plug into that API to instantiate new virtual machines. Now, on the other one was about the data issue. Yeah, how to move it. Yeah, well, this is actually, so it's very interesting with the big data, moving big data. This is happening already from the commercial customers. The key to moving big data is having many parallel streams of concurrent data. And it's going on already. But I could go into details with you about that later.
Okay, I can follow on because I think it follows on from these things. I think, well, 2 points. Firstly, I think data portability is very important for adoption. I'm involved with a environmental cloud service which we're developing, because a lot of people don't want to go to it because they think you're locked in and it'll be cheap at the beginning and the price will keep going up because you're locked into one supplier, and they don't want to go to that route because you can't predict their future costs. Even if it may be, they think it'll be more efficient, it also sounds like a car salesman in saying it. And the other point that's related to this, I think there's a fourth barrier. I completely agree with all the three barriers that we've come across, certainly in what we're doing, we've come across this a lot, particularly the governance issues. The fourth one is a lack of educated scientific customers or whatever, that people, a lot of scientists now don't get very good computing skills in their first degrees or even their PhDs. They get specific things because they're not sitting in an advanced computing environment. So they can't be the computing hero because they don't know enough to do it. It may not be the unknown unknowns, but it is for many of the scientists concerned.
Just one thing on this cost for data storage. Actually, the trend over the last few years has been to continue to see it drop. And so it might be going up someday. Also, I could talk to you about buying a car later. I've got a car for sale. Anybody else?
Well, I just wanted to make the general point that one of the good things about clouds is that you move your data up there and then you do your processing up there. So if we're worrying about data portability, people need to worry about moving your applications around as well.
Nigel Ward from Nectar. We're building a research cloud in Australia, a public research cloud in Australia. Got 4,000 cores at the moment, growing to 30,000 by the end of next year. Just wanted to comment on two reasons we think researchers like the cloud. One actually is the lack of a service level agreement. We think it allows researchers to innovate. They can spin up a couple of virtual machines, try something out. If it's successful, it can scale. And they haven't had to invest in their own infrastructure. So while I agree it's a barrier if you're moving into an operational phase, it's actually an advantage. It lets scientists innovate as well. And something else we're starting to see is the sharing of virtual machine images as a way of sharing science and repeatability of science. It's not just about making your code open source. It's creating a virtual machine image and allowing others to download that and install and use that as well. So just a couple of new advantages.
So I noticed that nobody listed standards as an inhibitor. And it seems like the grid standards apply a good bit, but the cloud community hasn't come kind of to participate in the grid standards. So I was wondering if, you know, whoever on the panel wants to address that.
You ain't gonna fall for that?
Yeah, thank you for giving me the pleasure to respond to that. Well, standards, you know, they are definitely something that cloud should look into that. I think they didn't come up that strongly as we saw, you know, well, we have been discussing standard in the context of grid computing for the last 10 years. But I think, you know, grid really originated more in the scientific and academic environment. So clearly the interoperability was a much more felt important issue. Cloud, they've been essentially originating in the commercial world where, you know, interoperability is not that strong. Now, there are attempts, I know about in Europe, there are attempts in Europe to discuss and decide when and how is the right time to introduce standards, because, you know, the usual dilemma, if you introduce them too early, you might actually distort and, you know, kill the innovation. And if you wait too late, well, then it's too late. I mean, you know, as the verge. So we have, and again, encouraging people to attend events. We have been running an event, you know, when I say we, the cloud community in Europe, we have been running an event called Cloudscape for the last 4 years. We're going to have another of this event in February in Brussels, where, you know, industry, standard organization like NIST from the United States and similar organization from Europe are going to get together really to discuss and address this issue. So yeah, it's something that we should look into.
So I'm feeling brave, so I'll say something about grid standards and cloud standards. So,
yeah, right.
So I think the difference is this, that what grids were about was about different organizations who had their own management regimes sharing resources. And for that to work, what you needed was standards to do the basic things. So you needed a security standard so people could authenticate themselves against different organizations' systems. You needed standard ways to transfer data between different organizations. You needed standard ways to kick off execution between different organizations. So it's absolutely necessary in the grid flow for people to have some sort of an agreement on how to communicate between organizations. The cloud world is different because what's happening is that in general people are just grabbing low-level resources from a cloud and building whatever software they want just in one lump on one cloud, and therefore it's under just a single management regime which they create. And so I think that's the difference, which is why the grid world had a focus on standards and the cloud world hasn't until now.
And one final comment on standards is that there actually is a lot of standard work that's going on. It is not the same level as what was happening in the grid world, and as you know, I know that world pretty well myself. But for example, in areas such as government compliance with standards in Europe, and in data, sort of the data locality issues that happen in Europe, and that Europe is working on standards there that the grid providers have to work with. We have things like HIPAA compliance, a lot of different compliance issues, security issues, authentication issues. These are things that are actually happening. And to the extent that, you know, Microsoft has decided that we will support Linux as something of an interesting thing for us and sort of fun. That's now pretty much a standard capability on every cloud. So it's happening, but it's happening driven largely by government and by big commercial customers.
Okay, hello. My name is Chris van der Meijden. I'm the CIO of the veterinarian faculty of the Ludwig Maximilians University in Munich. So I'm one of those IT guys you've been picking on here. And I'm not convinced in cooperating with the cloud for my faculty, and I can tell you the reason why. It is what I see is that we are running for both for the same kind of money. There are 100 millions I heard in the EU, and I would like to have that too. Yeah? And I could do very, very good things with that. And so there has to be a reason why the cloud should take that part of the money, and why the cloud could do those things better than I can do that. I am convinced that you can do that better than I can, but there's one thing that I'm missing here in the discussion, and that is privacy and freedom of research. We see in all those parts where cloud computing is starting to live, like Facebook, Google Mail, etc., all these things, that profiles are made up from the use of those systems. And what is your opinion on privacy? What is your opinion on profiles of the researchers? What are you going to do with that? Are there policies on that? Can we rely on those? And that are the questions why I say, I don't know if they are the right partners.
Free services. So in some of those, you're actually talking about free services like Gmail and some of those, which you're getting something for free. So you have to also make sure you differentiate between the two.
Yeah, I think that's a very good point. Those businesses that are essentially, they are buying information about you. And that's why they give it, you think you're getting it for free. You're actually selling your identity to them. And you're not getting paid very well, by the way.
Yes, okay. I agree on that there is a difference between a commercial system and a free system, but there still is the possibility of doing something else with the data, of what we are doing there. And that is something which is, I think, a part of human being, that you are concerned about that. And I didn't hear any information here on what is going to happen with these possibilities.
There's a difference between, I think, the customer, for a cloud provider, the customer is usually a business. And that business then has access, to its, it sets its own policies and rules and agreements with its customers. The cloud provider, for example, Microsoft, has no access to the data that a customer has in the cloud. We can't look at it. We don't have access to that. So for anybody that's using our Azure can layer on top of any sort of encryption they want, in addition to the fact that we have no access. It is really a contract between the user with the cell phone using their thing, or anybody that does that. So you have to, it's essentially a buyer beware in that sense. We will provide whatever protection our customers want.
Wait.
Oh, I agree. The comment was that it is and this is, I think, a very important point. What do people do? It's as you said, the shadow of the data, the history of your actions in the cloud. That's right. And that's something where we're happy to help protect people with.
Can I ask a really naive question? This is piggybacking off of the gentleman's comment there about if I'm understanding correctly, about the privacy and the profiling concerns in academic research. I spend a lot of time working on science metrics, and I know that it actually, in trying to push for better transparency for academic research, unless it's dealing with something where there are legitimate privacy concerns, such as clinical research or something that's under HIPAA, that it actually would be better for academic research to be able to know what sort of actions people and how people have been engaging with data. So I was wondering if you could elaborate a little bit more on what your fear and your concern is, or if it is just fear, or if I'm just misunderstanding.
Well, this is a good discussion.
So sorry, I didn't find out where the question came from. Okay. Oh, okay. Sorry. What I'm concerned about is that if I do any research on data. That and when I do that local, then I can be sure that everything that happens on this data is controlled by the local situation. When I put this research into a cloud, then it can be analyzed what happened, as I said, the shadow of the data. So it's not what's inside of the data, but it's how the data has been managed. It is, I want to decide when I go public, and I don't want to be public from the beginning of my work. No, it's just the first stage that I want to make up my mind, and once I made up my mind, I want to have the decision what is going to happen.
I just wanted to add the public clouds in particular, they want to make money, and if this ever happens that a customer's data was disclosed, it would become very public very quickly, and they would lose a tremendous number of customers. That's not to say it won't happen, but there are significant business ramifications if something like that happens. And so I would like to naively believe they put a sufficient amount of protection and attention to this issue.
Which is why we went out and made sure our cloud was HIPAA compliant, and that, and so in terms of our security of the facilities, I can't even I work for Microsoft. I can't get into those data centers myself. The security is so high. But I think the point that was really interesting, I think, was about the difference between scientific data provenance and computational provenance, and that making that available. So when you do go public with your research, to be able to also say, here's how I came to this conclusion. Here are the steps in my scientific process. Here was the maybe even the blind alleys I went down. Here is how I got to my result. And that is part of the scientific process. And I think exposing that is very, very important. But as you say, not before you want to do it. I mean, it should be completely private, and and we'll help you protect that.
I actually got a question for the first speaker. He mentioned this concept of scientists as service providers. Where are these scientists who are willing to actually be service providers?
Well, I think we've got one here who's been doing that sort of thing. I think there may be others in the audience that are doing that sort of thing. I suppose from the point of view that actually most researchers want to do research, they don't actually want to sit there and actually run a long-term service. And there's a different mentality around doing that, around actually making sure the services are stable and that sort of stuff. I mean, organisations run services. Researchers and research groups don't tend to run long-term services. They use the cloud, and one of the major advantages of the cloud is that you can actually do short-term things fairly efficiently. I also question the concept of actually having large data collections in the cloud. One of the problems we've got down under is the fact that the transfer rates of actually moving a petabyte of data into the cloud just make it impossible. It's just the costs are just too high. Yeah, no, I agree the problem in Australia, we need to have clouds down there, so that's a great thing. I hear one is being built, that's terrific. But in terms of communities running services, I think you can find there's some very good examples in the social sciences. The data curation service at the University of Michigan is run for 50 years as a service for the social science research community. You have also within the life sciences, I think we'll start to see services emerge. The point is, if you have something that is valuable enough as a service that it can be self-sustaining by a community and even employ people at some point to maintain it, then you have something that's truly valuable. But I agree, an individual researcher doesn't want to devote their life to maintaining a certain, although there are people that do that, and by and large it's not a large number. They're heroes, though.
So I think there are a number of services that are out there that people have created. And I think the main gap at the moment is business models to sustain those services. So the real problem that we have is that typically what happens, we create something for one project or a set of projects, and then when the project ends, then the entropy takes over and the software deteriorates, and something which might have had many staff years of effort going into it, which could be widely used, deteriorates. Now, the hope of the cloud is that, well, you could have got a nice model for the utilization of IT resources, because you don't need to pay. You don't need to get capital to replenish your servers to keep it going. But it's the software that's sitting on that, and whatever you have to pass on to the cloud infrastructure providers. And I think that's something that's not really clear. I often hear that scientists aren't prepared to pay for anything, although, as was pointed out by Ian Foster in his talk earlier, they'll pay for MATLAB. A lot of them seem to do that, and they'll pay for Office with Excel, which a lot of them use. But I don't think we've found a good business model yet for these services which are now cropping up, which will allow them to be sustained over the years and the decades which they really need to do.
I think Neil here has to introduce yourself. So I'm Neil Chuhong from the Software Sustainability Institute in the UK, and you almost took my entire question there. I think just following on from that, we're seeing that a lot of people, as you say, Paul, are willing to pay for these services, but we don't quite know what the model is to give recognition or reward or make people have the right business models to provide these services. It's interesting that Dennis put up the slide on things like IPython Notebook. I think these are the sort of things, you see Galaxy, for instance, being available in cloud services and so on. But my questions for the panel are really, the first of all is if we do manage to get an ecosystem of these kind of services being provided, how can we tell which ones are the best ones for the community to pick up? And then the second question following on for that is, how do we ensure that all of the people who just now are just looking for tools, the people who really just want to run MATLAB in the cloud and so on, how do we make sure that these people can get to the stage of knowing how to pick up something like Galaxy in the cloud and so on?
So I think that's quite interesting, because in other sorts of cloud services, then we've got the idea of recommendations, and people click to like things and so on. And at the moment, we don't really have that for these sorts of cloud services, except in particular instances like My Experiment, for example, where you can get information about which workflows people are actually using. But it'd be interesting to see whether the sort of social networking concepts that we've seen in other areas will start to be applied to science. So when a new, let's say we've got a framework where people can release services into the cloud, whether there'll be ways so that you can look at the provenance and you can see how this was created. You can look to see who's using it. You can look to see people's opinions on it. But we're not yet there. But it'd be interesting to see whether that actually comes to pass.
One small comment. One other way of doing this, of understanding and evaluating different tools in the cloud, is I see through competitions. The cloud actually could be a pretty good platform where if you have a data collection. For example, there's a project going on to do comparison of machine learning techniques based on a standard set of collections in the cloud, where you upload different machine learning models and you see which ones work. And it's a way of promoting high quality, interesting new applications. But it's the same with open source software. How do you know which is the best stuff? It's a really important problem.
Yeah. So my question may be a little bit vague, but I find the cloud hard to use for high performance computing. That is, in terms of the other things that people are talking about, it's great. You know, I use SkyDrive, all my stuff's out there. If my laptop died right now, I'd lose nothing in terms of work. So that kind of small scale computing, which, that may be the long tail, the cloud is wonderful. But it turns out that when you're trying to do high performance computing, for example, there's a big difference between a bunch of separate machines versus big machines with shared memory. And for example, and that seems to be hard to specify when you're doing cloud computing. And you can, I ran into an example where my laptop with 4 processors was faster than what I was running. So so I guess it relates to just the previous comment. It's hard to find people that can work through this. I'm finding it hard to teach myself how to do it. And to me, that if I look at this chart, I'm over at that right-hand column. That, I like the cloud. I don't care about data privacy. I'd love to take some of the money I currently spend managing our own systems and, pay somebody else to do it. But I have trouble doing it, is what I'm running into.
So I've watched Jeff work, and I've seen the challenges he's had, and I've actually seen the example that he talks about where his laptop was much faster than Azure to get some computation done. I agree. I think we've got a long ways to go. One of the reasons that we started to put an HPC cluster inside the cloud, that Amazon went ahead and did it, is people were coming and saying, this is not enough. Question I get very often is, oh, wait a minute, I need something with big memory, really big memory, and that's important.
Okay, I think we just got one final.
Well, I'm, have the honor. My name is Yuki Bei from the Center for Earth System Science at Tsinghua University. I guess my quick question is regarding utilizing the public cloud platform for the data storage and access. We have been continually educated that, putting the big data on the cloud, and we do not need to worry about the local, hardwares and IT support. But on the other hand, we need to pay for the data storage as well as for data access. So I'm wondering, is there any, comprehensive, realistic use case-driven study to show that the economic advantage of utilizing public cloud for big data storage and access? Thank you.
Yeah, there have been many studies and on this subject, and of course a little bit difficult because often we compare, a pear with apples, because it's very difficult to calculate, particularly in a research environment, the full cost of providing services. In my short talk, I mentioned that often those systems are staffed by a PhD student or so. So if you compare, and there is a comprehensive study was done a couple of years ago. I think I've seen Steve Newhouse down there by the by the EGI people or EGE on the comparing for CERN, CERN comparing the cost of storing the data on. Okay, so you can get the link to the study from Steve, but in general I think it's not easy to do because while the cloud are commercially provided, so you really expose the entire cost. When you start to compare that with the service provided to you by the local high performance computer center or others, often you hear the statement, oh, those services are free. Well, actually they are not free for the taxpayer. They cost a lot of money, but it's difficult to expose the entire cost.
Okay, I think it's a great question to end on. So I think we've certainly discussed all of these aspects, and I was a bit afraid earlier on that we wouldn't have enough questions, and we've actually had too many. So thank you very much to all the panel speakers and to you for your great questions. So.